Hello everyone. In this video, I'll be discussing about insert operation at heap data structure. So in my previous video, we have learned about left child, right child and parent, which is there in a array representation of heap. So basically there are various operations which we can perform on the heap. The first one is the insert operations. Then the next operation is extract. So either we can extract the minimum value or we can extract the maximum value from the heap depending on which type of heap is there. If the heap is min heap, then the operation will be extract min. If the heap is max heap, then the operation will be extract max. The second operation will be like get. Either we can get the minimum value from the min heap or we can get the maximum value from the max heap. Or the next operation is uh, delete. So we need to delete the node from the heap. Then heapify. So heapify is the important operation. Okay, so this operation is the important operation which we are going to discuss in later videos. Then decrease decrease or increase key. Okay, decrease or increase key. Then build build heap. So these are the operations that we need to perform in the heap data structure. So in this video, we'll be discussing about insertion in heap. Okay. So we'll be considering min heap for this example. So suppose I'll be drawing a min heap 4, 6, 8. Okay. Now this is a min heap. Okay. It's a complete binary tree, and moreover the root value is the smallest value as compared to the descendant values. Okay, now suppose I need to insert a value, say 1. I need to insert 1 in this min heap. Okay, so first, like what we can do, we can make an array representation of this min heap. So this will be at index 0, this will be at index 1, this will be at index 2, and this will be at index 3. Okay, now I need to insert this value. So what we can do is that suppose I am having an array representation of this min heap. This is index 0, 1, 2 and 3. So the value at index 0 is 2. Then this will be 4. This will be 6 and this will be 8. So what is the size of this array? The size of this array is 4. Now for inserting any value in a min heap, I'm going to insert this value at the end of the heap. So I'm going to insert this value at the end of the heap. Okay, step 1, insert it at the end of the heap, like insert it at the end of the array. After inserting it at the end of the heap, the next step will be compare the value with the parent's value. Okay, so newly inserted node is having value 1 and the parent value is 4. Okay, so what is the main aim? The main aim is to convert it to a min heap. Right now, due to this node, the min heap property of this heap gets disturbed. Okay, so after adding it at the end of the heap, the next step will be compare it with the parent's value. So the parent value is 4. So if the parent value is greater than the newly inserted node, then we need to swap the value. Okay, so on swapping the value, like we need to swap the value of both this. On swapping the value, it will change to 1 and this one will be 4. Okay, this one will be 4. Now again we need to compare this node with the parent value. So basically the first step is insert it at the end of the heap. The second step is compare the node with the parent node, and if the parent node is greater than the newly inserted node, then swap it. Okay, so this is the case of min heap, because in min heap the main aim is to make the smallest value to be present at the root, or to be present at the top of the larger values which are there in the descendant nodes. Okay, so now again I need to compare the value at this node with the parent node. So the parent node is 2, is having value 2, and the current node, this node, is having value 1. So again I'll be swapping these two values. Now this will be 1 and this will be 2. So after inserting 1, the new heap will be like 1 will be at the top, this will be 2, the 8, 4, and this one is 6. So this is the insertion process. So the step 1 will be insert the newly node in the end of the heap, or we can say at the end of the array. Now after inserting it, what we need to do is that we need to compare this with the parent node. Okay, so in array representation, suppose the newly node is 1, so I'm adding it at the end of the array. I'm going to increase the value of the size, and after increasing the value of the size, it's very easy to find the parent value. Okay, if I am at 4, the parent value will be in I minus 1 by 2 floor, which is 3 by 2, which is 1.5, and the floor value of 1.5 is index 1. So the parent value of this is 4, like the value at index 1. Okay, so it's very easy to find the parent value in case of an array representation. For understanding purpose, we can use this tree diagram. So what we have done is that we have added this newly created node at new node at the end, and after that we need to compare the value with the parent value. So in case of min heap, the main aim is to make the smaller value present at the top as compared to the descendant values. Okay, so on comparing the value with the parent value, like if the parent value is greater than the new node value, then we need to swap. We need to swap the values. Why we need to swap the values? So that the node having the minimum value will be on the top. Okay, node having the minimum value will be on the top. So 4 will come over here and 1 will come over here. Now again, if we are at this node, we need to check for its parent node. The parent node of this node is this one. So the value was 2 and over here the value is 1. Again the parent value is greater than this value. So we need to swap the values. So after swapping the values, we have inserted 1 in this heap and we got the modified heap, this one. Okay. So in case of max heap, what we need to check, if the parent value is smaller than the new node's value, then swap it. Then swap the new node's value and the parent value. But in case of min heap, if the parent value is greater than the new node value, then swap. So the operations which we are going to perform in min heap will be the opposite in case of the max heap. So this is all about insert operation.